The asteroid Bennu, a dark and ancient visitor from the dawn of our solar system, has captivated scientists since its discovery. Orbiting over 200 million miles away from Earth, Bennu holds secrets that predate our planet. NASA's OSIRIS-REx mission embarked on a daring journey to collect a sample from Bennu, and what they found when they opened the sample container shocked even the most seasoned scientists. Let's explore the incredible journey of OSIRIS-REx, the challenges of sampling an asteroid, and the groundbreaking discoveries made upon opening Bennu's treasure trove. Bennu is no ordinary asteroid. Its carbon-rich composition and loose rubble structure make it a cosmic time capsule, preserving materials from the birth of the solar system 4.5 billion years ago. Bennu's surface is littered with rocks and fine grains that have remained largely unchanged, making it an ideal target for studying the building blocks of planets and the origins of life itself. The asteroid's proximity to Earth, it comes within 300,000 kilometers every 6 years, and its potential hazard trajectory in the 22nd century added urgency to NASA's mission. Launched in September 2016, NASA's OSIRIS-REx, Origins, Spectral Interpretation, Resource Identification, Security Regolith Explorer. Spacecraft spent over 2 years traveling to Bennu. Upon arrival in December 2018, it began an extensive survey of the asteroid, mapping its surface and selecting a suitable site for sampling. The mission's objectives were ambitious: collect at least 60 grams of material and return it safely to Earth. In October 2020, OSIRIS-REx executed a maneuver known as TAG, Touch and Go, briefly landing on Bennu's surface to collect samples using its robotic arm. The process was far from smooth. Bennu's unexpectedly loose and soft surface caused the spacecraft to sink deeper than anticipated. Despite these challenges, OSIRIS-REx successfully gathered an estimated 250 grams of material, far exceeding the mission's goal. Afterward, the spacecraft embarked on its journey home, traveling millions of kilometers before finally releasing its sample return capsule into Earth's atmosphere in September 2023. When the sample container was opened at NASA's Johnson Space Center, scientists were greeted with an unexpected surprise. The outer lid and surrounding components were coated with a significant amount of fine, dark dust and small particles, far more than anticipated. This bonus material was not even part of the main sealed sample chamber, hinting at just how abundant and volatile Bennu's regolith truly is. Once the sealed chamber was carefully accessed, the findings became even more astonishing. Initial analyses revealed complex organic molecules, the presence of carbon-rich compounds, including amino acids, essential for life, potentially offering clues to how organic material could have seeded early Earth. Hydrated minerals, microscopic inclusions of water-bearing minerals, confirming that Bennu's parent body once harbored liquid water billions of years ago. Unusual isotopes, isotopic compositions of oxygen and other elements that are distinct from Earth's, providing insights into the formation of the early solar system. Pre-solar grains, tiny particles older than the Sun itself, carried to Bennu from distant stars long before our solar system formed. The Bennu sample provides an extraordinary window into the primordial materials that shaped not only our solar system, but potentially the origins of life itself. These samples, untouched for billions of years, hold a wealth of information about the conditions that existed before Earth was even formed. Scientists believe that studying Bennu's material can unlock secrets about the early solar system's chemistry, the building blocks of life, and how planets like ours developed. The discovery of complex organic compounds, including amino acids, lends strong support to the idea that asteroids like Bennu may have been crucial in delivering the precursors to life to early Earth. This bolsters the theory that life on our planet might have celestial origins, seeded by organic-rich asteroids that collided with the surface billions of years ago. Equally compelling is the detection of hydrated minerals, evidence that liquid water once existed on Bennu's parent body. Water is a fundamental requirement for life as we know it, and its past abundance on Bennu suggests that the ingredients for habitability could be more widespread across the cosmos than previously thought. This discovery has profound implications for the search for life elsewhere, indicating that water-bearing asteroids might be common carriers of the chemical essentials for life. Adding another layer of fascination are the pre-solar grains found within the sample. These ancient particles formed in the fiery cores of long-extinct stars serve as cosmic breadcrumbs tracing back to the processes that predate the birth of our Sun. They remind us of the cyclical nature of the universe, where star formation, destruction, and rebirth continuously supply the material for new worlds. Bennu's grains offer a direct link to this grand cosmic recycling process, providing clues about the life cycle of stars and the genesis of solar systems. In essence, Bennu's samples are much more than fragments of an asteroid. They are a tangible connection to our cosmic origins. By studying these ancient materials, we not only unravel the mysteries of the past, but also gain a clearer understanding of the processes that led to the emergence of life. These insights expand our appreciation of the universe's complexity and the profound interconnectedness of its many parts. The journey is far from over. Scientists will spend decades analyzing Bennu's material, using state-of-the-art methods to delve into its ancient secrets. High-resolution imaging and spectroscopy will provide detailed maps of the sample's chemical and mineralogical makeup. These techniques, combined with innovative tools like synchrotrons and electron microscopes, will allow researchers to study individual grains at the atomic level. Through this, they aim to uncover the processes that shaped Bennu over billions of years. Moreover, comparisons will be made with samples from other missions, including JAXA's Hayabusa 2 mission, which returned material from the asteroid Ryugu in 2020. By integrating data from Bennu and Ryugu, scientists hope to create a comprehensive profile of carbon-rich asteroids, exploring their similarities and differences. These comparisons will also offer insights into the diversity and evolution of asteroids across the solar system, helping to refine models of planetary formation. The studies could also extend into unexpected realms, with potential findings influencing fields like astrobiology and cosmochemistry. From discovering rare isotopes to detecting previously unknown organic compounds, Bennu's material holds the potential to transform our understanding of the solar system's history and the origins of life on Earth. The OSIRIS-REx mission has demonstrated humanity's remarkable ability to reach out to distant worlds, collect ancient cosmic materials, and bring them home for study. It stands as a testament to the ingenuity and determination of scientists and engineers who dare to explore beyond the confines of our planet. The discoveries from Bennu not only enhance our understanding of this mysterious asteroid, but also weave a deeper narrative about the vast, interconnected story of our solar system. This story stretches back to the very dawn of time, tracing the formation of planets, the origins of life, and the evolution of the celestial bodies that continue to shape our existence today. What secrets might still lie hidden within Bennu's fragments? Could they reveal new insights about the origins of water, organic molecules, or even the mechanisms that seeded life on Earth? Only time, further exploration, and the unyielding curiosity of humanity will uncover these mysteries. The journey to unlock Bennu's secrets is just beginning, promising even more groundbreaking revelations in the years to come. If you're fascinated by the mysteries of the universe, we invite you to take part in our ongoing exploration. Don't just stop at this video, there's an entire cosmos waiting to be uncovered. Be sure to like this video, subscribe to our channel, and hit the notification bell so you'll never miss a moment of discovery. Each like and subscription helps us bring more of the wonders of space right to your screen. Let's journey together through the stars, unraveling the enigmas of our celestial neighborhood one video at a time. Thank you for your support, and we can't wait to see you in the next adventure among the stars.